Well, we're going to pick up with 1.2b now. We finished for the properties of 1.2a, and we're just going to pick up a few more properties here and practice a few combination ones where we're using all the properties sort of at once. That's really what we want to get to. So let's just jump in and knock these other properties out. Now what we have is what we call power of a power. And so remember, the a to the m is a power. And so what's inside is a power, but also the whole thing is a power. So that's why they call it power of a power. In other words, if you have a base that has an exponent and another exponent is raising that power to some degree, then what we want to do is we want to multiply those exponents. And so when they're right next to each other, which makes sense, think about what we do just in regular numbers. Here, let me put a number up here. I have a parentheses, and then let's say I have like a 3 next to it, or a 4. If I gave you something like, I'm going to put another parenthesis. If I had something like that, how do we, we've been taught that that's multiplication, that the parentheses means multiplication. So here's the same thing. If you notice what separates the two exponents is simply a parentheses, that's going to be a multiplication of those exponents rather than an addition like it was when bases separated. So sometimes we get these two mixed up. If you remember what we had earlier with multiplying powers, notice that the exponents are separated by a base. And so when they're separated by a base, that's called a where we're multiplying powers or we add exponents. When it's separated by parentheses, we want to multiply the exponents, base stays the same. Watch your order of operations. That's going to be really the only tricky part here, in my opinion. So in something like this, when we don't want to do the double negatives first, I've got to go ahead and do -2 cubed because exponents must come before multiplication. So -2 cubed is simply -8. So -2 times -2, 4 times -2, -8. And then I've got the negative out in front. And now I can go ahead and address this as 8. Now, for that problem, if you went ahead and did the two negatives and then cubed it, you would have got 8. And so you would have, checked your answer in the back of the book or whatever it may be and been like, I know what I'm doing. And so it's important. The answer is important. I'm not saying it's not, but the answer is important, but it's part of the puzzle. We need to make sure that we're doing the properties and the arithmetic and all the operations properly as well, even if we do get the right answer, because it may be the right answer the wrong way. Looking at the next one, again, we have a negative exponent. I'm not going to deal with it. What I see is power of a power. So I'm going to leave that -3, and I'm simply going to multiply those two, and I get -12. Now I'll deal with the negative exponent, which means how do we make a negative exponent positive? So back in 1.2a, flip it. What's the it? It's the base. So x is my base. I flip it down to the denominator, and that allows me to make my exponent positive. So 1 over x to the 12th. Okay, moving to the next property called power of product. I sort of use this a little bit early in 1.2a. And so this is where what we have is a exponent, and we're raising a product to that exponent. Now, make sure that we understand there's a huge difference between these two expressions. We have a product and we have a sum, or if it's a subtraction sign, a difference. Huge difference. This property is not used in addition and subtraction because now we're not dealing with a single term or what we call a monomial. We're dealing with multiple terms. And so a good rule of thumb is this right here, okay? This expression right here needs to be expanded because you can never ever take an exponent across a plus or minus sign. So help you God, you would owe me soft snickerdoodles. So if you take this exponent and try to just share it to both a and b, you would take that exponent across the plus or minus sign. In other words, it's not a monomial. You're trying to use a property that doesn't exist. So when we get a situation like this is called a binomial expansion. And we'll do binomial expansions in pre-calc, even large ones with Pascal's triangle and factorials and binomial coefficients and things like that. So we will get to that at one point. But right now, you should not be taking an exponent across a plus or minus sign. So help you God, you would owe me soft snickerdoodles. Not the crunchy ones, the soft ones. They have to be soft. Okay, so let's go ahead and use this property here. Every time we use this property, it seems like the power of a power property comes into play. So I'm going to go ahead and share this cube to each of those three. So it's now, don't multiply -3 times 3. That's an exponent. So -3's exponent is really just 1. So -3 cubed is what we have. And so -3 times -3 times -3 is -27. Now, what we get for the second one is we have x to the fourth, and then I'm cubing that. So notice they're right next to each other. So this is our power of a power now, and that's x to the 12th. So power of a product a lot of times takes us to power of a power. And then what we have is y to the fifth, and we're going to cube it. Again, it's power of power, so we get y to the 15th. This is not a negative exponent. You do not flip unless it's a negative exponent. We're done. It's just a coefficient. Looking at the next example, you can do this a couple different ways. You could share the -3 exponent and then do some manipulation there. And there's nothing wrong with that. I do tend to see students struggle a little bit when it's a numerical, like a coefficient, numerical value that's raised to a negative exponent. They start thinking it has something to do with it being negative again. And negative exponents have nothing to do with things being negative. They mean inverse or multiplicative inverses, which is reciprocal. So we flip things. So another way of doing this is I'm just going to go and I'm going to go ahead and flip the x inside. So I'm going to make the inside exponents positive if I can. Now, in doing this, what it allows me now to do is it allows me, instead of sharing, okay, what I can do is now I can take the fraction I have, that's the base. The 6 over x squared is my base. And I'm going to, there's a negative exponent, and I'm going to flip my base. So flip the fraction. And then that allows me to make my exponent of the base, so the -3, it allows me to make it +3. Okay. Now, that's going to lead us into the next, now to go from here and to simplify, it's going to lead us into the next property. But I want to show you what I would do on this problem. So we're going to end up, just to let you know, we're going to end up getting x to the 6th on top, and you're going to end up getting 6 cubed on the bottom. Now, 6 cubed, just to let you know, is 216. So that's going to be our answer. But let me show you how to do this using our properties and just verify it's going to be x to the 6th over 216. I'm going to go ahead and share this. Okay, so I get 6 to the -3. And when I share it to the -2, what happens is -2 times -3 is 6. So I get here. Now look, I have a negative exponent. So flip the base with the negative exponent. And then 6 cubed, like I said, was 216. And so there we go, x is 6 over 216. So see, that property works by sharing it. I'm just telling you from past experience, students tend to have I don't know, for whatever reason, have a little bit hard time with that right there. They just they see it a little differently than with variables. And so a lot of students will tend to go sort of this route because it makes more sense to them. And both are perfectly fine. Got to figure out what works best for you is the key. Okay, and follow those properties. So I mentioned that I was going to end up using a new property, and that's our last one called power of a quotient. Well, we shared with a product. We are now sharing with a quotient. And when we share, we don't leave anyone out. So if I have a base that has an x and a y, just like this one, I'm going to share to the x and to the y. Let's say there was a 2 in front of the x and a 3 in front of the y. Then I'm going to square the 2, square the x, square the 3, square the y. I am sharing and taking that exponent to each factor inside of my base. That makes up my base. So in this case here, if we share it just to x and we share it just to y, we're done. There's nothing else you can do with this. Those aren't common bases. Looking at the second one, very similar. What we have is y to the 6 and then squared. And so when we have something like that, we have power of a power again. So it looks like this. And so that ends up being y to the 12th. And in the denominator, we have x squared, which is x squared. And so there we go. That's going to be our two answers there. Looking at just sort of our last things that we want to look at here is just some combinations. And so this is where things start picking up. So when they're individual properties, things don't really look that messy, and it's like, okay, this is really easy. However, then it starts getting a little bit more complicated when we start throwing a lot of these properties into a single problem. So a good rule of thumb is simply to look at something like this expression here and ask ourselves, what do I see, and how do I know if I'm simplified? So how do you know if expression's simplified? There are no more parentheses, no powers raised to a power. So in other words, we have single powers. A base only occurs once. So like here, I have n on top and bottom. That's not simplified. Like I can only have a base of n, either in the numerator or denominator, and no negative exponents. So a problem like this one right here, again, you can start this different. You can flip the n. You can do dividing powers. I have power of a quotient since we just got done with that. Let's go ahead and I'm going to do that way. So 3 cubed is 27. So remember, it's not 9, it's 3 cubed. M to the 6, because square, I'm sharing this to each of these, is what I'm doing. And then n to the negative 3, negative 1 times 3, and then n to the ninth, 3 times 3. Now, I'm not done, but I'm really close. I have a negative exponent. I'm going to flip this, and then I think we'll be done because there's no common bases anywhere else. So when I flip this down to the bottom, I'm going to go ahead and write it over here so I can put my final answer over to the right. Now what I have is n to the ninth n cubed. So I'm multiplying common bases, and whenever you multiply bases, you add exponents. So it's like bringing down an extra 3 n's. And so there's our final answer for that. If you look at the example just to the right here, let's go ahead and look at it. A lot going on. You can jump in and do a lot of different things here. First off, I see x to the 0. It's like it's not even there, so I'm going to take care of it. Looks like I'm going to do a lot of sharing. I'm not going to deal with the negative exponents right now. I'm going to get rid of all these bubbles. Now, a lot of times students are like, well, how do you know to do that? I didn't know you're supposed to do this. One way of knowing that is simply through a lot of practice. I mean, there isn't just a you do this and then you do that every single time. There's different paths you take. So you'll learn what you see and where you're going to go. It's a little bit like a chess game. You know what the end needs to look like. It's this stuff right here. And so we just need to sort of make our lives as easy as possible throughout the process of getting there. So as I share, I get x to the fourth, and I get y to the negative 2. And then on the right one here, I get 5 cubed. Now 5 cubed is 5 times 5, which is 25. And if you have 5 quarters, which is another 5, it's $1.25. And then is that a 5? Oh, that's a 3. Yeah, I think I said 5, but 5 cubed is 125. And then y to the negative 3. So this is called power of a power. We multiply, and we end up getting something like that in our numerator. And so you can see what I'm going to do next in the numerator is going to be multiplying power. So I'll show you that in just a moment. But let's go ahead and do the bottom. We get 9 x to the negative 6 y squared. And I'll put that in its grouping symbol. And then what we have over here, this one's actually a little easier. It's x cubed y to the ninth. And now I'm ready to do, now what I'm going to do is combine the two up here using multiplying powers, and the same on the bottom. So I'm going to definitely have 12, or excuse me, 125, that 5's still there, times 1. How many x's do I have? 4. Now, when I do the y's, when you multiply common bases, you add the exponents. So I should get negative 11 of those right now. Looking in the denominator, I have a 9. Now, 125 and 9, there's no common factor, so it's simplified right now. But always look for that. Always look to cancel. X's, it looks like I'm going to have negative 3. Now, how I arrived at that is I did multiplying powers. I added the exponents and keep the base the same. Same with the y's. I get y the 11th. And now what I'm going to do, personally, I'm going to go ahead and flip the ones that are negative. And so wherever I see a negative exponent, I'm going to make it positive by flipping it or moving it to another spot. So I'm going to have 125, and then I have x to the fourth, and then now I have x cubed next to it. That becomes positive. I've got 9. I've got the y the 11th already down there, and then another y to the 11th comes down. I do see students try to cancel these two. They're not the same, so they wouldn't cancel each other out, so that we should be doubling up on that one, I think. And so 125 x to the 7th, so when you multiply powers, you add exponents, and then y to the 22nd, so we did double up there. And there's our final answer. There's nothing else we can do. Okay, so there's an example there. Let's look at maybe just a few more examples here. I have them hidden. And so let's look at one like, oops, sorry, that one will get out of the way. Let's try this one right here. All right, so let's try this guy, see what's going on. So I look at this one, and you could share the square, and actually it'd be perfectly appropriate to share it. I'm going to go ahead and flip the B, though. I like working inside, and so I'm going to flip the B. Everything else stays the same. So that should be a parentheses right there. And then I'm going to square each one of these. So -2 squared is -2 times -2, which is 4. And then share it to the A and share it to the B. And there we go. There's our final answer. Okay. So there's another example for you to look at. Let's see if I can get that one out of the way. Let's see what else we got underneath here. Okay. So let's look at one like this one. This is a good one to look at. You can work inside. I think that would be good too. Personally, I see these -1 exponents. Okay. So, and whenever I have a negative exponent and the negative exponent is the power of a fraction. So notice that right there is tied to this fraction right here. Typically what I'll do is I'll take the fraction and just flip it. Now, the stuff inside the fraction does not change signs. I'm not doing anything with the things inside. All I'm doing is making that outside exponent positive. So that -1 stays -1, that -3 stays -3. Okay? I'm going to do the same thing with the second one. I'm going to flip the fraction itself, which is the base. So flip the base, make your exponent positive, but the base doesn't change. So I shouldn't be changing those negative exponents. Once I get here, you can, I see, like I may bring those two up. And so I end up getting x to the 5th because that 1, when I bring it up, I can add those exponents. I get y to the 7th. And so there's my left one. And then over here, I can do the same thing. I get x to the 6th and y to the 5th. And I just really have got one last thing, which is when I multiply powers, you add exponents. Base stays the same. And there we go. So really complicated looking one, but able to work through it and get some answers to work on there. Okay. Okay, those are good examples. You just got to keep practicing as much as you can, and the more you practice, the better you get at these. I think you'll end up utilizing a lot of skills that you've done prior to pre-calc to be successful here. But we want to get very efficient and competent at this exponent properties because you'll be using it tremendously in calculus to manipulate some of the information.